welcome to Tennessee's At Home Learning Series. Today's lesson is for all our fourth graders out there, even though anyone is welcome to tune in. Today is the 16th lesson in our series. My name is Miss Pereira, and I'm a fourth grade teacher here at Venus Stewart Elementary in Gallatin, Tennessee. If you didn't see any of our previous lessons, you're more than welcome to tune in today, but we do encourage you to go to www.tennessee.gov/education to find our previous lessons since we will be building on our knowledge. Today we will be learning about division with remainders. Before we get started, so that you can participate fully in our lessons, you're going to need a paper and pencil and a surface to write on. You're also going to need 20 items to use as counters. These can be beans, pennies, anything, any small item that you could use and manipulate on your paper in front of you. And I'll give you just a few seconds to gather those materials. Today we're going to solve problems using division. So let's start by looking at this situation. Read along with me. 4 friends split a bill for lunch equally. The bill is $48. How much will each person pay for lunch? So what is this problem talking about? Right, we've got some friends who are going out to lunch, and the bill comes in, it's $48, and they want to split it equally among all 4 friends. So what information do we know? Correct, we know that the bill was $48. What else do we know? We know that they want to split it between 4 friends. So what is it that we're trying to figure out? Correct. We're trying to figure out how much each person will pay for lunch. So what operation could we use to figure this out? Are we going to add, subtract, multiply, divide? Very good. We're going to divide because we've got a total split into equal parts. So how could we divide 48 by 4? We can call these numbers the dividend and the divisor. The dividend is 48, the total amount of money that is being split into equal groups. The divisor is 4, the number of equal groups we're splitting them into. In this case, it's the number of friends. So we're thinking about how many times 4 will go into 48. One way is to think about multiplication. Let's list some multiples of 4. Let's make a list. So we know 4 times 1 is 4. 4 times 2 is 8. 4 times 3, 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 8, 32. 4 times 9, 36. 4 times 10, 40. 4 times 11, 44. 4 times 12, 48. So these are multiples of 4. We listed the first 12 multiples of 4, and here we see in the 12th multiple a 48. So 4 times what gave us 48? Correct, 4 times 12. Remember that multiplication and division are related. We know that 4 times 12 is 48. So that also means that 48 divided by 4 is 12. The division sentence says that 4 goes into 48 12 times. So 12 is our quotient, or the solution to our division problem. So let's think back to the question about what each of these numbers mean. We know that the 48 is the $48 or the total cost. We know that our dividend 4 represents the 4 friends that they're going to split the $48 between. So our 12 is how much each person is going to pay for lunch. Each person is going to pay $12. For the next division problem, we're going to use some items that you have around the house, some counters. So take a moment, if you didn't already, and gather 20 small items. I'm going to use counters that look like this, but you can use anything, 20 small items. If you can't find 20 items, it's okay. You can just draw little dots on your pencil and paper. Okay, so let's look at another problem. Andrea and 2 friends are playing a game of dominoes. There are 20 dominoes in the set. Andrea wants each player to receive the same number of dominoes. Can she divide them equally among the 3 players? So we can use division to find the number of dominoes each player will receive. So let's draw a picture to kind of model and help us think through this. We know that she wants to split the dominoes equally between 3 friends. So let's draw 3 circles. Each circle is going to represent a friend. And then we're going to use the 20 items that you gathered, or you can just draw circles, as our dominoes that Andrea is trying to share with her friends. Remember, the question wants to know, can she divide them equally among the 3 players? So that's asking, can all 3 players get the same amount with these 20 dominoes? So let's just share them. Let's divide them up. Let's give each friend a domino until we're out of dominoes. Do this with me on your paper, or you can just color in a dot in each circle until you've drawn 20 dots. So I'm going to continue to give each friend a domino. So right now, they each have the same amount. We've got 3 equal groups. I'm going to keep going because I've still got some dominoes left over here. I have enough to give everybody one more. And when I go, now I only have 2 dominoes left. So I don't have enough to give everybody one more. And I know that Andrea wanted to divide them equally. So I'm going to have these 2 extras because it's not fair if I give these 2 friends an extra domino and not this friend. So these are just going to be extra. So we just modeled a division problem with a remainder. Our extra that I was talking about is what we would call a remainder. What division problem did we just model? Correct, we had 20 counters and we wanted to divide them up or split them up or share them equally among 3 groups. And we were trying to figure out how many could go in each group equally. So each friend got how many dominoes? Correct, 6. 2, 4, 6. 2, 4, 6. 2, 4, 6. But then we had these 2 left over that didn't divide or split up equally, so we call those our remainder. And we label that with an R, remainder equals 2. So remember that 20 is called our dividend, or the total number of objects. In this case, they were dominoes. 3 is our divisor. In this problem, the divisor was the number of people. And we found that we could equally put 6 objects in each group with 2 left over. So 6 is our quotient and a remainder of 2. To revisit this problem, we found that when we divide 20 dominoes among 3 friends, Each friend receives 6 dominoes, with 2 left over. Awesome job. Let's keep going. Let's look at another problem. So I'm going to clear off my work area. And let's look at another problem together. Students are driven to soccer games in vans. Each van holds 9 students. How many vans are needed for 31 students? So what information are we given in this problem? Let's go back and reread. We know that students are driven to a soccer game in vans. We know that each van holds 9 students. And what is it that we're trying to figure out? Correct. We're trying to figure out how many vans are we going to need for 31 students. So they're trying to get 31 students to the soccer game. How many vans are they going to need? So what strategy could we use to figure this out? Right, we're going to use division. We know the total number of students is 31. This is the dividend. We're going to divide the total number of students by 9, the divisor, or the number of students that could fit in each van. So let's write that problem on our paper. We're trying to figure out 31 divided by 9 to figure out how many vans they're going to need. So let's draw a picture. You draw with me. I'm going to draw a rectangle to represent each van, and I'm going to figure out how many students fit in one van. It told us 9, and I'm just going to draw dots inside the rectangle to represent each student. So first van, let's draw a rectangle. And how many students can fit in each van? Correct, 9. So I'm going to draw 9. We need to drive a total of 31 students to the soccer game. So we have to keep drawing vans until we've drawn 31 students or 31 dots. So in this van, we've got 9 students. So let's draw another van. We can fit 9 more students in this van. So now we have a total of 18 students put into vans. But we need 31 students, so we have to keep going. So let's draw another van. That will fit 9 more students. So all together, so far, we've put 27 students into vans. But we need 31, so we have to get another van. "27 students, 28 students, 29 students, 30 students, 31 students have been put into vans. We drew 31 students, but the last van isn't full. That means we have a remainder. 31 students split equally into vans of 9 students fills up 3 vans with 4 students left over. As a division equation, this would look like this. 31 divided by 9 equals 3 full vans with a remainder of 4. Those 4 students who didn't fill up an entire van. In this situation, what will the quotient and remainder, or our solution, represent? Correct, the 3 is the 3 vans, and the remainder 4 is the 4 students who didn't fit into a full van. Can 3 vans be used to drive all of the 31 students? No, because there are still 4 more students who have to go to the game. So how many vans do we need to drive all 31 students to the soccer game? Good job. We would need 4 vans because we still need that 4th van, even though it's not full, to carry these other 4 teammates to the soccer game. Okay, let's look at another problem. Read along with me. Ben is a tour guide at a museum. He can take no more than 7 people at a time on a tour. If 80 people want to go on tour, how many groups of 7 people will Ben show around? So let's just think about this problem for a second. We know Ben is a tour guide and he's taking people on tours through the museum, but he can only take 7 at a time. There's 80 people waiting in line to go on this tour. So how many groups of 7 can he show around? How many times is he going to have to give this tour so that all 80 people get to go on the tour? So we know that he can take no more than 7 at a time. We know there's 80 people that want to go. We're trying to figure out how many groups of 7 will he show around. What would this look like as a division equation? Correct. We take the total amount of people we had, 80, and we're going to divide it by the amount that he can take in each group, 7, so that we can figure out how many groups of 7 does he need to take. This time, I'm going to think about fact families to solve this problem. 7 times what number is close to 80? I know 7 times 10 is 70. That's pretty close to 80, but not quite. So I'm going to keep going up with my facts from there. I know 7 times 11 is 77. Still not quite the 80 people. And I know that 7 times 12 is 84. Too many. That's more than the 80 people. So 84 is more than 80. So 7 times 12 is going to be too much. 7 times 11 is 77, which doesn't go over my 80 people. So I know that 80 divided by 7 is going to be 11 with a remainder. I know that 77 is only 3 away from 80, so I'm going to have a remainder of 3 people. So the quotient is 11. Ben can give tours to 7 people at a time. The quotient is the number of tour groups of exactly 7 people that he can take. After he completes the tours for groups of 7, how many people are going to be in his last tour? Great, the remainder is 3. So that means Ben's last tour is only going to have 3 people in it. If Ben gives tours to all 80 people, how many tours will he have to give? Correct, 12 tours. 11 tours with exactly 7 people in the group, and then a 12th tour with only 3 people in the group. Not all real-world division problems require the quotient and the remainder as the answer. We have to interpret the problem situation and the question in order to determine what answer makes sense. The answer can vary sometimes. The question might be asking for a quotient without a remainder. Sometimes the question might be asking to explain what the remainder means in the problem. Thank you for thinking through these different ways to interpret a quotient and a remainder with me. Now, let's do some more practice. Get your pencil and paper ready. Work through this problem with me as I think aloud. Daniel made 32 ounces of soup for 5 people. How many ounces of soup will each person get? Okay, so I know that he made 32 ounces in total and that he wants to be able to serve 5 people. So I'm trying to figure out how many ounces of soup each person will get. Okay, So I'm going to need to divide because I'm taking a total amount and I'm dividing or splitting it up between 5 people. So let's go ahead and write our equation on our paper. 32 divided by 5 equals blank. How much soup each person is going to get. I understand that Daniel's feeding 5 people with 32 ounces of soup. He wants everyone to get the same amount of soup to be fair, so he's going to need to divide. I'm going to think about multiples to solve this problem. Since division and multiplication are related, 5 times what number is close to 32? I know that 5 times 5 is 25 because I'm pretty good at my 5s. 5 times 6 is 30. Still not quite there. 5 times 7 is 35. Too much. I didn't have 35 ounces of soup. I only had 32, so that won't work. Ooh, but this one will work. 30 is really close without going over. So I know that 32 divided by 5 is going to be 6. But I'm going to have some soup left over that didn't split equally among the 5 people. Because when I gave each person 6 ounces of soup, I only used up 30 ounces of soup. So I still have 2 ounces of soup that are going to be left over that didn't divide or split up equally. So I know that 32, my total amount of soup, divided by 5, the 5 people who I'm sharing the soup between, equals 6 ounces of soup with a remainder of 2. So each person is going to get 6 ounces of soup. Okay, now you try. I'll give you a little guidance along the way, but I want you to see what you can do on your own. Read along with me. A total of 14 students sign up to be greeters on Parents' Night at school. The principal wants an equal number of students to greet parents at each entrance. There are 3 entrances. How many students will be at each entrance? So let's go back and think about this problem for just a second. We know that we have a total of 14 students that are there to help. We know that the principal wants the same amount of students at each door, an equal number of students to greet at each door. And we know that there's 3 doors or 3 entrances. So we're trying to figure out how many students can be at each entrance. Remember, with the same amount of students at each entrance. So let's think. We're taking those 14 students and we're splitting them up, right? So 14 split up or divided by 3, the 3 entrances equals how many students at each door? You try this one on your own. You can draw a picture, you can use your multiples or related fact families to help you solve, and then we'll check it. What did you find? 4? Yes, very good. Is there a remainder? Yeah, because 4 times 3 is 12, which is 2 away from 14, so there's a remainder of 2. So I use my related fact. I know that 3 times 4 is 12, meaning if I put 4 students at each door, I'm using 12 of the students. So I can put 4 students at each door, but then I have a remainder of 2. We only use 12 of the students. There's still 2 students left who need a job. And I'm sure the principal will find something helpful for them to do. Okay, let's do one more. You do it on your own, and then we'll check it together. Mira has a 17-foot roll of crepe paper to cut into streamers to decorate for a party. She needs each streamer to be 2 feet long. How many streamers will she have? Okay, how many 2-foot long streamers will Mira be able to cut from her roll of crepe paper? I heard 8 streamers. Very good. Will there be any crepe paper left over? Yes, there will be 1 foot left over. I'm sure she'll find something else to do with that remaining paper. Your problem might have looked like this. 17 divided by 2 equals blank. We know that 2 times 8 is 16. So she's able to get 8 2-foot pieces, but that would use up 16 foot of her paper. And 16 is 1 away from 17. So she's going to have 1 foot left over. Great work, everyone. Today we practiced division with remainders. I hope you're seeing that sometimes when you divide, you'll end up with some left over. You really did a great job. Here in a minute, I'm going to show you some problems that you can practice on your own for independent work. You can also find these problems in a printable version at www.tennessee.gov/education. Thank you for inviting me into your home today to learn with you, and I look forward to seeing you at our next Tennessee at Home Learning Series lesson.